Okay, I was sent this problem over the internet, and so I'm going to talk about how you would approach a solution for it. Um, Here is the network that you're given. You can see there's a router in the center and 4 hubs, and then there's 3 hosts on each hub. And in this scenario, what we have is we have 4 networks, right? We have 4 networks, 4 Ethernet ports on this router connected to a hub. That's going to be an Ethernet connection right there. So you've got 4 networks that you're going to have to create addresses for. And then here was the question. And I've put a note here. Notice that no subnet mask is given in the question. So in the question, they omit a subnet mask. So it's kind of a problem, but we can just assume what they want. But they say this, something like this, and I changed the numbers to protect the innocent. Given the address 192.168.5.0 and given the diagram, given the address 192.168.5.0, given the diagram, create the appropriate number of subnets, right? Well, we saw in the diagram there's 4 networks, so we will need 4 subnets, right? We'll need 4 subnets there, but they want you to allow for 11 more subnets. So we'll just say here 4 plus 11 equals 15. So we're going to need 15 subnets. Why? The diagram has 4 networks and they want 11 more subnets. So we need to create 15 subnets from this starting point right here. Then once we have all our subnets and our address worked out, the PCs are going to get the lowest addresses on the subnet and the routers will get the highest addresses on each subnet. Okay, and so that's no problem. But before we can deal with this, we have to figure out our subnetting. So we're going to assume that they mean a starting point of 192.168.5.0/24, right? Now that's what they've given us. They've given us the 5 network here, and we need to subnet it into multiple networks. And essentially what we need to do is turn it into a minimum of 15 subnets, right? So a /24 subnet mask, and that's what we really need to figure out here, is what's our subnet mask. A /24 is a 255.255.255.0 subnet mask. And the important thing to remember here is that the zeros represent the hosts. So you'll have 8 bits of hosts in the last octet. Now I'm going to highlight this last octet because this is really important right here. So you can see here I've made this bold. So this is the first octet, the second, the third, and the 4th octet in the subnet mask. So right now that would be all zeros, right? And in a situation like this, you'd have the host portion right here, the zeros, 1, 2, 3, 4, 5, 6, 7, 8 zeros is 2 to the 8th power, or 256 hosts. Okay, 256 hosts. Now, you can't use the network number, the first number, and you can't use the broadcast number, the last number, so it's 256 minus 2 equals 254 hosts. All right? So that's our starting point, 1 network, the 5 network. Okay? Now let's see how we can carve this network up into subnets. Now, the first thing we could do is we could say, well, we'll change that to 255.255.255.128. All right? If we do that, in this last octet, we put a 1 here, right? And now our magic number is 128, okay? And it creates 2 networks, the 192.168.5.0/25 network. Now notice this would be 25. And the 192.168.5.128/25 network. So that would create 2 networks. Okay, if we change this to 128 and made that a /25 instead of a /24, that's putting 1 bit here. Now our magic number is 128, and that tells us how many where the networks are. The first network always starts at 0, and the next network would be 128. Also, you could say this is the number of hosts. Now we have 7 bits in the hosts. So for hosts, we have 2 to the 7th power, or 128 hosts. The magic number also tells us the number of hosts. And we have 1 bit for networks, which gives us 2 networks. So let's move on down the line. Now, if we change it to /26, then this turns to 192, right? And this is a 1 here, and 128 plus 64 is 192. The magic number is now 64, and the networks would now be 0, 64, 128, and so on. And you would go up, and the next one would be 192.168.5.192/26. So we'd have 0, 64, 128, and 192. And we'd have 4 networks. Okay, how do we have 4 networks? Our network bits, our subnet bits, are 2 bits. 2 to the 2nd power is 4. And how many hosts would we have? Well, the magic number would tell us that. We'd have 64 hosts, or 2 to the 6th power. All right, but we need how many networks? We said we need 15 subnets. So the correct answer is changing this here to a 1 and this to a 1. So our magic number is 16, and our networks will go up by 16. But more importantly, our network bits are, we've got 1, 2, 3, 4 network bits. So 2 to the 4th power is 16. And we have 4 host bits, and 2 to the 4th power is 16. So we would do a /28. Our subnet mask would be 255.255.192.224.240. Why 240? 128 plus 64 plus 32 plus 16 is 240. And our networks will go up by 16. So this would be 16, 32, 48, and of course these have to change to /28 subnet masks. Now, how many are we going to get? Well, we can look really closely here and say, well, we've borrowed 4 ones from our original subnet mask of 255.255.255.0. 2 to the 4th power is 16, so that'll give us 16 networks with 16 hosts available for each network, right? Our first network will start at 0, and it will run through to 192.168.5.15, right? /28. So 0 is the network address, 15 is the broadcast address. The next network is 16. Broadcast, network, next network. Notice how the networks go up by 16 every time, and the magic number is 16. Okay, so we already know that the next network is 192.168.5. We add 16 to that, we get 64/28. And we add 16 and we get the next network, which is 5.80, and so on and so forth. So that gives us the appropriate number of subnets, 15 subnets, and all we had to do was have enough hosts, enough host addresses to meet the requirements of the diagram. And in the diagram, each network has only 3 hosts. So we have plenty of addresses for a 3-host network.